What's up, everyone? So in this video we're going to talk about segmentation, as this is one of the requirements or one of the points on CCIE security blueprint. And more precisely, we're going to cover VLANs and private VLAN. Now, I won't dive too deeper around VLANs because right now this is I believe a known topic. So VLANs we often use when we want to segment to place uh, different devices on different networks. And we often do this by using different VLANs, and these VLANs they are associated with a different layer 3 network. For instance, we have these routers here. They're sitting on network 10.0.70/24, which means that 34 should be able to reach 35, 37, and 39. Now, and in case we have the requirement that the 34 and 35 they shouldn't be able to reach each other, and without changing the network. So in this case, we could use a private VLAN. Okay, because if we were to use VLANs to place on a different VLAN, then we would have to make a way so that they would still be reaching these other devices on the same network. With private VLANs, what we can do, we can place devices on the same network, kind of different VLANs, and we can dictate to which devices, to which ports we want them to still communicating. And private VLANs, they have this concept of primary and secondary VLANs. A primary VLAN is the one that is able to reach all the other secondary VLANs. As for secondary VLANs, we have two types. We have the isolated and the community. Isolated VLANs, they are used to prevent the communication with other isolated VLANs, and they only talk with primary VLANs or primary VLAN. As for community, they are able to reach the same devices on the same community VLAN and the primary VLAN, but they're not able to communicate with devices on a different community or on an isolated VLAN. Okay? So I created a script just to speed things when I'm going to test. So right now, let's see. 36, it should be able to reach all the other devices in the network. As we can see, should be able to reach 7, 34, 35, itself, 37, 38, and 39. And we're going to see that it's going to change. What we're going to do is to place 34 and 35 on isolated VLANs, and 36 and 38 we're going to place on a community community VLAN. 37 and 39 we're going to place on a different community VLAN. And at the end, we should see that all the routers, they're going to reach R7. 34 and 35 they should reach only R7. 36 and 38 they should reach only each other and R7. And 37 and 39 they should reach each other and R7. So let's start the configuration. So we have to do this all on the switch, and the first requirement is we have to enable the switch to run on transparent mode or VTP version 3 in case we want to propagate the private VLAN information using VTP. In this case, we only have one switch, so we're just going to set the switch to run on transparent mode. Now, we're going to need 3 VLANs for this. Actually, we're going to use 4. One is going to be the primary VLAN, where we're going to place R7. And the other ones, we're going to create a secondary isolated VLAN where we're going to place 34 and 35, and two communities, one for 36 and 38, and another one for 37 and 39. And so let's start with going to call VLAN 7 and VLAN 71 to 73. Okay, VLANs are created. So far, easy. Now we have to say that VLAN 7, it's going to be a private VLAN primary, and we have to associate this private VLAN with the secondary VLAN. So private VLAN association 71 to 73, and it's done. Now we have to tell the secondary VLANs their role. So VLAN 71, that's going to be a private VLAN community. The same for 72. And 73 is going to be an isolated VLAN. Okay, and VLANs configuration are done. Now at the port level, you start the configuration. So this is where R7 is sitting. So I just want to speed things up with spanning tree. And to start by saying switch port mode private VLAN, and this mode private VLAN, and this is going to be a promiscuous port, and switch port private VLAN, and what I want to make is mapping between our primary VLAN, that's going to be 7, and the secondary VLANs 71 to 73. So let's confirm that. So this is a promiscuous port, and I'm associating or mapping the secondary VLANs to the primary one. Now let's configure the port where 34 and 35 are connected. So interface range on 3 and GL2. Speed things up, and let's say switch port private VLAN, and what I want to say is this is no. So first I have my mode has to be private VLAN. This is going to be host, and switch port private VLAN, then host association, and the primary VLAN and the secondary. So this is going to be an isolated one, so it's going to be VLAN 73. As for the interfaces, G03 and G11, so switch port host, switch port mode private VLAN host, switch port private VLAN host association, the primary and secondary 72. As for each one, G10 and G12, switch port host, switch port mode private VLAN host, switch port private VLAN host association, the primary and the secondary. So let's confirm that my promiscuous port is enabled, and my isolated port, it is configured as well as let me see, G03. Yeah, so everything should work just according to plan. So let's run the script again on 36, and let's do the same on 39. So we see some changes already on 36, and let me bring 34 as well. Let me paste that, and 35. Okay, and let's see. 6 still running, 4 still run. So 6 already finished, and we should see a successful to 7, not to 34, not to 35, 36. It's its own IP, 38, and but not to 39. So working like it is supposed to. And for 39, and this is another community, should be able to reach R7 on not 34, nor 35, nor 36, 37 it's okay, not 38, and 39. As for 34, it is connected on an isolated port. You should only have successful packets to 34. Is it? Yes. And 7. Everything else should be dropped. So as you can see, this is quite simple configuration for private VLANs. And I hope you guys enjoyed, and I'll see you on the next one.